This is the summary for Lesson 12, Systems of Equations from Unit 4. So we are into understanding systems of equations. And a system of equations is a set of two or more equations that have variables that represent the same unknown, and I would put here units, the same unknown units. So in this example that we're going to use, we have x represents the number of days and y represents the height. So the units are days and the units for y are height. And in this case, we have two plants. One plant starts out at 3 feet tall. The other plant starts out at 6 feet tall. And those plants grow at different rates. One plant grows at 1/4 of a foot each day, and the other plant grows at 1/2 of a foot each day. And here are the two equations for this system. So down here, you have one tool right now, a main tool right now, solving this kind of system of equations. And that's by graphing these two equations and looking at the point at which those two graphs intersect. And the x and y values at that point will be an equal value. So you have the same x value in both equations, and you're going to get out the same y value. So x and y will be equal. So here's a graph of those two equations, and here are those two equations. So in this situation, you have plant A that grows, that starts out at 6 feet tall and grows at a slower rate than plant B that starts out shorter. It starts out at 3 feet tall and it grows at a faster rate. So of course they will intersect somewhere, and your task is to find that point of intersection. That's the solution to both of these equations, because at this point they will both be 9 feet tall after 12 days. So they've grown for 12 days and they are both 9 feet tall. So how do you figure that out? Well, that's the subject of the next few lessons, but let's get an idea of how you can conceptually look at it. How can you visualize what's going on? So they start out at 3 feet apart. So the difference in the y-intercepts is 3 feet. So 6 feet for plant A, 3 feet for plant B. So they are separated by those 3 feet. And the question is, how many days does it take to close this gap? So plant B is growing faster, so it's gaining on plant B. And how long does it take for plant B, in essence, to catch plant A? Well, they're growing at different rates. Plant B is growing at 1/2 of a foot each day, so it gains 1/2 of a foot each day on plant A, but plant A at the same time is growing 1/4 of a foot each day, so that grows further, that's farther from plant B each day by 1/4 of a foot. So the net gain, how much this gap closes each day, is the difference between 1/2 of a foot each day and 1/4 of a foot each day. So this gets closer by 1/2 of a foot, this gets farther away by 1/4 of a foot. So the rate at which the two graphs move to the intersection is the difference in these two slopes. And it turns out that that is 1/4 of a foot each day. So how long is that going to take? Well, if you start out at 3 feet apart and you're going to take out 1/4 of a foot each day, that's a division problem. 3 feet is the length divided by 1/4 of that of a foot each day. That answer is 12 days. 3 divided by 1/4 equals 12 days. So it will take 12 days for these two plants to be at the same height, and that's the solution, which is 9 feet, and that's the solution to both equations, or the solution to the system of equations. So you're going to see 3 different types of systems of equations. So in this example, we had two plants that after 12 days, they were both 9 feet tall. In some cases, you're going to have a system where there are no solutions, and that's when those two lines are going to be parallel. 2 or more lines will be parallel. So there won't be any solutions. You have situations where you have just a single solution, and that's this example that we just looked at. That's where those two lines intersect. That's one solution. And finally, you're going to see situations where you have infinitely many solutions, and that's where the two equations and the two graphs of those equations end up right on top of each other. They are in essence the same equations, and so that has infinitely many solutions. So this is what we're going to look at in the next few lessons.